Hello and welcome. This video will walk you through a very simple Java program in JGrasp. In the upper left hand corner, you want to click File and then New and then Java. You will see that the menu presents you with several options. You can get the file Rectangle Test at our class Blackboard site. It's a text file, so when you open it, it will open in a browser. You can hit Control-A to highlight the entire file, and then Control-C to capture or copy it. You could then go to JGrasp, put your cursor in the development window, and then hit Control-V to paste. And you will have some Java to play around with. Let's go ahead and try to compile this file. We hit the green plus button. This does not run the file. It only attempts to compile it. Let's give it a shot. Right away, we'll be asked to name the file. Now, this is extremely important. In Java, the class that contains the main module, right here, is called the driver class. This is the class that Java will look for as the program starting point when you run the program. It is critical to note that the name of the Java file you are creating and the name of the driver class must match exactly. This is case sensitive. So if the driver class is the one that contains the main method, I look for it and I see that the main method is in the rectangle test class. So I want to name my file rectangle class. So I'm going to go ahead and compile this by hitting the green button. I hit save. You can save this file in other places, but for now I suggest that you save this to whatever folder JGrasp defaults to. For me, that's Documents. You can see that JGrasp has already assigned a file name based on the class driver I have already created. The file name is the exact same case as what I have for my driver class, and the file has a .java extension. This looks good, so I click Save. Down below in my compile messages, I see a note that says Operation Complete. This means that my Java code has successfully compiled. Let's run the code and see if it works. To run the code, click the little red Running Man button. Down below, we see a bunch of outputs, which I'll go over in a minute. For now, it looks like it's running. So let me back up and go over a few things. One thing I like to do is turn on my line numbers. I go to View and I click Line Numbers. The reason I like to do this is because when I have an error, the compiler usually gives me the line number. So, for example, at line 15, I'm going to break my code by taking out the semicolon. When I attempt to compile the program, the compiler gives me an error. It's kind of hidden. It says rectangle test.java:15. The 15 tells me the line number. Now, don't be fooled. This doesn't always work. Note that if I fix that error, but I take out the bracket at line 19 and I attempt to compile, I'll get a line that says that my error is at line 62, which is the very bottom of my code. My error is not actually at 62. It's at the spot that the code was looking for that closing bracket, which again was up here at line 19. So that's not a hard and fast rule, but starting at the line where you were told to look for an error is a good rule of thumb. Most of the times, that's pretty accurate. This is a good time to point out why we indent certain parts of code. Indenting makes it easy to line up the brackets and other parts of our code so that we can quickly see if obvious parts are present or missing. In Java, single line comments can be made by 2 forward slashes. Comments are lines that are ignored by the compiler. I subscribe to the belief that code needs to be self-documenting, so I like to use a lot of comments. As you can see, the first 4 lines of this program are comments that tell me the name of the file, who created it, and the date the program was originally created. And now I'm going to modify the program. So I've added a line that notes the modification. To find out more about comments, please refer to page 5-9 of our green textbook. The very important statement on line 6 tells Java that I want to import a functionality. Specifically, I want to import the ability to output something to the screen, so I want to import the I/O package and all of the classes in it. The asterisk means everything. It means bring in all the classes and functionality within the I/O package. On line 8, I'm creating my driver class. The word public means that something outside the file can access the class. If it's private, the compiler couldn't find, read, or execute it. On line 9, I have the opening bracket of the rectangle test class. You'll note that the closing bracket for the rectangle test class is on line 19. Everything between these brackets is part of the rectangle test class. On line 11, I begin the main method. The key point here is that, at least for now, our programs must have a driver class that matches the name of the file, and the driver class must have a main method. The upshot is that when a program runs, the Java compiler knows to start the program in the class that has the same name as the file. Once it gets in that class, it should start looking for the main method. If you have not read Chapter 6, this is a good time to pause this video and read pages 6-1 to 6-9. On lines 12 and 17, we see the opening and closing brackets for the main method. On line 13, I'm going to declare a variable called rec. Rec is an object of type rectangle. The rectangle class is defined starting on line 22 and ending on line 62. On line 14, I tell the program to instantiate the rec object. The upshot is that lines 13 and 14 just create an object. They don't do anything to it. On line 15, we are going to call a method that is created in the rectangle class. To examine this, let's skip down to line 22 and examine the rectangle class. Understanding classes and object is a whole topic in and of itself. The most important thing to know right now is that the rectangle class will have variables as well as some methods that can act upon those variables. Notice that immediately following my declaration of the rectangle class, I have an opening bracket. On line 62, I have the closing bracket. Anything between the opening and closing brackets is within the rectangle class. Please note that the rectangle class is not defined within the rectangle test class. The rectangle test class is defined from lines 9 to 17, while the rectangle class is defined from lines 22 to 62. These classes do not overlap. On lines 27, 28, and 29, I declare three variables: height, base, and area. When I create each variable, I need to assign a data type to it. If you don't yet understand types, this is a good time to pause this video and read pages 7-2 and 7-3 of our green textbook. You will notice that I have assigned values to the variable height, base, and area. You may also have noticed that the area is wrong. The area of a 4x3 rectangle should be 12, not 11. We will fix this in just a minute. At this point, I invite you to pause this video and examine the code for the three modules that are part of the rectangle class. Those modules are appMain, showArea, and fixArea. Examine these methods now and see if you can figure out what they do. Resume the video when you are ready. Please take as much time as you need. To start with, we see that there are three modules in the rectangle class. The methods are appMain, showArea, and fixArea. This diagram shows us the relationships between these methods. In this case, the appMain method is the central method that calls the other two methods. appMain will call showArea and fixArea. Unlike the main method in the rectangle test class, the appMain function does not need to be called appMain. You could call it start here, main method, or lemon jinx. This name is not special. We will stick with app main for now. At line 15 of the program, the app main method was called by the rectangle test main driver method. So control of the program goes from line 15 to line 31, and we fall into the app main method. At line 33, the first thing the app main function does is output a note to the user that says, "You are in app main." This is what I call a note to self that allows me to follow the program as it progresses. If I run the program, you can see in the output that the first thing the program outputs is "You are in app main." The next line, line 34, tells me the measurement of the base of the rectangle. In this case, we see the system.out.println command doing its job. What we want output must be within the parentheses. If we want to output text, we need to put that text into quotes. In this case, the plus symbol is not telling Java to perform addition. In this case, I'm saying append the value of the base variable to the text that I want to output. In computer programming, appending things together like this is called concatenation. And I can say that this line of code will concatenate the text "the base of the rectangle is" to the value of the variable base. If I look down at the output, I can see that the output is the text concatenated to the value of the base value. This is another way of thinking about it. The blue code creates the blue output, and the purple variable name creates the purple output. As you can see, I like to output little notes to myself to tell me that my variables are working and to tell me the values of these variables. I do this for the base in line 34 and for the height in line 35. At line 36, I call the function showArea. What is happening here is that the app main method is temporarily giving control of the program over to the showArea method. App main method will effectively be put on hold and not do anything until the showArea method has completed its tasks. The showArea method starts at line 41, where it is defined. The body of the showArea method is defined from lines 42 to 49. The first action for the showArea method is line 43, which outputs a note to myself that I am now in the showArea module or method. As you can see, the outputs are below. Make a note that at this point my area variable is still set to 11, which is not the area of a 4x3 rectangle. At line 47, I make a note that I am now going to leave the showArea method. At line 49, the method quits and returns control of the program to line 36 of the app main method. At the end of line 36, there is a semicolon, which tells the computer go to the next line, so the computer goes to line 37. Line 37 tells the computer to execute method fixArea. So once again, app main is put on hold and control of the program is given to the fixArea method, which starts on line 51. The first line within this method is line 53, which is a note to self telling me that I have made it safely inside the fixArea method. I want to know what the area is, so I run line 54. This line will output the value 11, which is what I originally set the area variable to at line 29. Line 55 tells me that I want to fix the area variable. At line 56, I multiply the base variable by the height variable and assign the value to the area variable. At line 57, I have a system.out.println statement that concatenates text for the user to the value of the area variable. As you can see in the output, the value of the area variable has been changed from 11 to 12. At line 58, I tell the user that I will be exiting the fix area method, and we then go to line 60. At line 60, the bracket control of the program goes from the fix area method back to the app main method. The app main method ends at the brackets at line 39, and the class and the program then end at line 62. This is the end of the 101 video. Please continue with the lesson by watching the 202 video.